Today's video is going to talk us through graphing systems of equations and graphing linear equations. We'll have this review and then you'll have a graded assignment. So the first thing to let you know, there are 3 eggs now. So the hawks have laid their 3rd egg and they're going to just be tending to them. I don't know if there'll be a 4th. So let's go ahead and get started. So we're going to review the linear equations and solving systems by graphing. You can take notes, you can watch, you can do a mix of both. A graded assignment follows this lesson, so make sure that you are really focused. So let's review. The slope-intercept form follows the form y equals mx plus b. And since you have an assignment to follow, you might want to copy this down. A line with a slope of 4, so it's important to remember the slope is that letter m. So that would be your slope, and a y-intercept of -2. So again, remember your y-intercept is that b. That's where it crosses the y-axis. It would have the equation y equals 4x. So I'll write it above here. Y equals 4x. And it has a y-intercept of -2. So instead of a plus, we'd have a -2. How we would graph that is we'd find our y-axis and we'd go down to a -2. We start with the y-intercept, and that slope of 4 really means 4 over 1, and it's rise over run. So we would rise 4 places and run 1. Once you make your 2 points, you can connect them and make sure you have arrows on the end. So that is the equation y equals 4x minus 2. So now we're going to graph y equals mx plus b. My equation for you would be y equals 1/3 x. And I want to point this out because this would follow the form y equals mx plus b, but there is no b given. So you need to replace in your head that with a 0. If you just see y equals something x, you know it starts at 0. And then you follow those same steps, rise over run. So rise is on top, run is on the bottom. You rise 1 and run 3. You go up and to the right because it's positive. If it were a negative number, you'd go down and to the right. So that would be y equals 1/3 x. Now let's suppose you're given graphs already. You're given this letter A over here, and then the letter B, and it says which graph has the smaller y-intercept. So y-intercept means where it crosses the y-axis. So here you can see it. It's right on the y-axis at -2. So here you know B is -2. Here you have to say, well, I remember this is y equals mx plus b. B is my y-intercept. B is 4. So which one is smaller? It turns out that the one that's smaller is this one right here because -2 is smaller than 4. So I'll just put a star by letter A. Which function has the greatest y-intercept? Now this time I'm going to draw it while you see it happening. So I'm going to put this here and you'll be thinking, what is that y-intercept? What did she just graph? So I'm going to draw this and we'll call this function A. Then I'm going to give you a choice of B, and I'm going to say y equals -3x minus 4. And I'm also going to give you a choice of C, y equals 2x plus 5. It says which function has the greatest y-intercept. So first thing you want to identify is you are looking for your B value. So 5 and -4. And the y-intercept here you can see is 2. So which one is the greatest? In this case, we would say choice C is the greatest because 5 is the biggest of those 3 numbers. So you want to make sure you're noticing what they're looking for. Now there are our special occasions, and these are vertical and horizontal lines. Everyone did a wonderful job of remembering that a vertical line has an undefined slope. What we had trouble remembering was what the equation was. So if we have the line x equals 5, we would need to say to ourselves, this means we start at our origin and we plot on the x-axis the number 5. Now, anywhere on the x-axis is not 5 because here, if I plotted next to it, would be 4. So I cannot plot that point. However, I can plot the point right above it because that is another spot where x is 5. It's the point 5, 1. And I can plot this one because that is another spot where x is 5. And you could plot any of those points, and when you connect them, you'll see that is a vertical line. Its equation is x equals 5. If we asked you to plot x equals 2, it would also be a vertical line. It would just go through the spots where x is 2. So the equation x equals a is where a represents any number. We have a similar equation where it's y equals b. So I think this one's a tiny bit easier because it would still follow the y equals mx plus b format. It just has a 0 slope. So what we're essentially doing is giving you that y-intercept. So let's say we have y equals 4. You might, in your brain, rewrite this as y equals 0x plus 4. And that lets you know that here is your y-intercept and it has a 0 slope. So graph y equals b is a horizontal line. Okay, so sometimes they ask us to write the equation. So let's look at the first one, that horizontal line. That would be where you identify it goes through the line, the point y equals 4. So you're going to say y equals 0x plus 4 or y equals 4. Your vertical one, equation number 2, it's going through the point x equals 2, so you would say x equals 2. Okay, so now we want to pick the equation for this line. So look at your line, it's in black, and first thing you want to do is identify the y-intercept, which I can see is 2. It's not horizontal or vertical, so I can promptly rule out choice A and choice B. And I see that it has a y-intercept of 2. Well, that's not good news for me. Both of the equations have a y-intercept of 2. So now I need to look at the slope. And the slope is positive. It goes a rise of 1 and a run of 1, up and up and then over. So because it goes up and over, it's positive. It has a slope of positive 1. It's choice C. If it were negative, it would go down and to the right. So your line would look like this. Now we're ready to move on to systems by graphing, and I'm sure this will look familiar. To solve a systems of equations by graphing, you graph both of them and you find where they cross. Okay, this is the biggest struggle for us, is remembering that that point is x and then y. So you may want to write that down on your paper. This is where they intersect. Remember, some systems don't intersect, so we'll also see that. So let's start with a real world problem. So this graph shows the number of followers 2 celebrities have on their social media accounts. What can you conclude from the point of intersection? So if I look here, this says number of weeks on the bottom, and on the side it says number of followers in thousands. So let's take a look at celebrity A, and we notice that at the start, celebrity A has 1 follower, but by the time they get up to week 18, they are looking at, and actually that's 1,000 followers, not 1 follower. By the time they get up to week 18, it looks like there are about 8,000 followers. And then if you look at the other one, they started with 8,000 followers and they're declining very quickly, and they're almost down to just 2,000 by week 18. So one is clearly gaining popularity and the other one is losing popularity. However, the question they're asking you is, what can you determine from the point of intersection? And what I can see is that after 10 weeks, they both have about 5,000 followers, and one is just on the up and one is on the way down. Now, sometimes you don't have any context. You're just asked to solve by graphing. You don't know what the situation is. So look at your first equation on the top. This is y equals 6x plus 0. So y equals 6x plus 0, put that in yourself, and that means you have a y-intercept of 0, and you have a slope of 6. So that means you rise 6, and you run 1. You can connect your points. Now this might be a time where it's helpful to do a third point. So instead of rising 6 and running 1, I can go down 6 and run to the left 1. So now I'll connect those points. And here is my first equation. I'm just going to call that equation 1 so I know. My second one, I'm going to go ahead and switch colors and call it equation 2 and put an underline. And it has a y-intercept of -2. And we go up 8 and over 1. So 1, 2, 3, 4, 5, 6, 7, 8 and over 1. When you're asked to solve by graphing, usually it will cross perfectly. When you get a little bit older into Algebra 1 and beyond, it may not cross perfectly. So our solution point is that place where they overlap. So right here, it's the point 1, and then you count up 1, 2, 3, 4, 5, 6. So my system of equations, their solution point is 1, 6, x, y. Okay, let's look at another. Okay, so here, notice we have this equation y equals 4. I've highlighted this because this is one of our special ones as well. This actually follows that y equals mx plus b, and what they're telling you is your y-intercept is 4 and your slope is 0. So you can graph that, and we'll just call that equation number 1. And then your second equation also has a y-intercept of 4. We'll do this as equation 2, and it has a slope of -1/3. So you can see that the two cross right here at this point. Now, sometimes kids get messed up with this one because of that ordered pair. So remember, it's x and then y. You stay still and you go up. So this would be your x term is 0 and your y term is 4. A lot of times people mix those up. Okay, and then we have some special cases. So you may not recognize right away that this is a special case, so just go about graphing it. Y equals mx plus b, y-intercept of 2, down 3, and over 1. That would be our first graph. And I'll just call this 1. And then your second graph, I'll switch colors. And you start with your y-intercept of -3, and then you go down 3 and over 1. And I hope you notice that they have the same slope and they have different y-intercepts. And you can clearly tell that they are parallel and they will never cross. So if they have the same slope and different y-intercepts, you would be able to tell without graphing that there is no solution. Your graph could be blank as long as you know they're parallel lines, there's no solution. And then there is another special case time. Now this one's a little trickier. Y equals 3x minus 9 and -3x plus y equals -9. This particular graph doesn't even have room for us to graph, and that's on purpose because I want you to notice that in order to get this into y equals mx plus b form, you would add 3x to both sides. When you do that, I hope it jumps out at you that y is equal to that 3x, we can put it first, so it's y equals mx plus b form, minus 9. Those two lines are the exact same. If they're the exact same, there's infinite many solutions. So they're the same line. There's infinite solutions. So of course you could count by 3s and you could fit this on, but you don't need to because you can tell they are the same line. And that is the end.